Hello, everyone. Welcome to something a little bit different. Normally, I do some Lorcana videos, but recently I have been really interested in this Microsoft Excel World Championship case study. So I figured I'd kind of show this case study to you guys, as well as kind of some tips, tricks, ideas, kind of how I solve this case study and the solutions here. So, just to give a little bit of background on what this is, essentially each year there's kind of a challenge for competitors to kind of solve these Excel case studies. And this one is pretty interesting. Essentially, I think Eve Online did a collaboration with Microsoft to showcase their Eve is a huge online game that has a lot of data, and so in order to help their players out, I guess there's some market data that's been kind of easily imported, exported into and out of Excel to help the players plan kind of buying minerals, planning their ships, and all of that sort of stuff. So Eve essentially, I guess, partnered with Microsoft to kind of showcase some of their integration, and so in kind of this Microsoft Excel case study, it's based off of an Eve kind of like structure. However, the good thing is you do not need to know anything about Eve Online in order to solve these case studies. Essentially, what these case studies are just challenges to kind of utilize Excel's tools in order to solve data problems. And all of the information is already provided within kind of each of these cases there. And so it's kind of cool to try to figure out how to use Excel's built-in functionality in order to solve cases, and kind of figure out the solutions to what seemingly is pretty complex problems. This case study can be downloaded in the Financial Modeling World Cup. You can get it. I think recently when I got it, it was free, but I don't know if it's gonna stay that way. I highly recommend going there and kind of downloading, grabbing this case study and trying it out for yourself if you're interested. Otherwise, spoiler alert, I will kind of go through how I reached the solutions in this case. I think it's going to be likely a 3-part video. And just so if you're ever curious, you can kind of follow along and see what some of us do with spreadsheets in Excel and how we solve various data problems. Actually, I kind of really enjoy these case studies because they really, while they seem complex at first, they really don't require too much, I guess, expertise. I wouldn't say I'm a expert in Microsoft Excel by any means, but at the same time, with just using, I think, like a couple of basic functionalities and some kind of programming logic, I was able to solve all of these problems in this case. So good to know. A lot of times you don't need to know in depth every little detail about what Excel can do. You just need to know the important functions and abilities Excel has, and you can solve a majority of your data problems. So just a little bit additional background on kind of this case studies are structured. It gives you instructions here. Most of the time, this is a competition involving 8 players in a race to see who can score the most points by answering the most questions within an hour, half an hour and a half, some amount of time limit. Just as full disclosure, I had already worked on this problem a couple of days ago. Took me, I think, about 7 to 8 hours to finish this entire case, score all of the points, and get all of the answers correctly. But that's from kind of just like a fresh look at it. I think, and plus, once again, I would say I'm not fastest at utilizing Excel or kind of being able to absorb information instantaneously and kind of work with it. So I think for me and for kind of the average viewer or for the average person working with this Excel, it'll probably take quite a few hours to kind of go through this problem. But having gone through it and kind of having a better understanding of this case, I think that a quick Excel user could probably solve this entire case in about 2 hours. That's my kind of guess on if I kind of knew most of the things, or if I had enough practice working with these cases, it'll probably take about 2 hours ish to solve. So having said that, an hour is definitely really difficult to solve a case like this. It just needs a lot of kind of really quick judgment decisions on how to kind of go about trying to answer the questions. But that's part of the competition, right? Likely you want it to be very difficult to score the full amount of points within the time limit you impose, just so that the people who are faster can score more points out of, I think it's 2,000 points. They can score more points than other players. Having said this, I am going to go through this entire case in a couple of videos, and it's going to seem like I'm going through it pretty quickly, but that's just because I've already gone through this case, figured out most of the tips and tricks, as well as some of the kind of confusing instructions that needs to be processed in order to arrive at the correct answers. If you think I'm going fast or slow or something like that, don't be daunted. It's because I've already spent a ton of time on this case, just thinking about how to address each of these questions and stuff. And simply, this is a video kind of for anyone who is curious at how to answer all of these questions. This is just one way that someone could do it. So without further ado, let's go into kind of the basic instruction and the layout for this case, and then I'm going to kind of, on a broad level, highlight how I'm going to break it apart. And so we can see the first part isn't super relevant. It's just a quick description of EVE Online. Oh, by the way, full disclosure, there are going to be a lot of spoilers, so I highly recommend, once again, that if you're ever interested in these cases, go ahead, go to the Financial Modeling World Cup website, download this case, give it a try for yourself, and then if you get stuck, maybe take a look at this video or ask questions or look online, and I'm sure you can find a lot of great tricks that you can use in Excel in order to solve these problems. Cool. Without further ado, let's go into the instructions. For minerals and ships, essentially what this case is telling you is that EVE Online deals with a bunch of different types of ships and minerals that can be used to build these ships. So there's going to be 5 types of ships and 7 different types of minerals. And ships will cost different amounts of minerals, and the minerals themselves has a market. So the currency is ISK, and mineral prices for each of the 7 different minerals fluctuate on a daily basis. And the prices are provided to you in this adding output. So you can see in this adding output, you have the dates and then the prices for titanium, pyrite, Mexilon, isogen, etc. All of the different types of minerals. So that's kind of the relationship between minerals and ships. The second portion of it, we can see it tells us that for levels 4 through 7 in this case, we're actually dealing with mining the minerals in different asteroids. So I think the case will also provide a table, but there's going to be 4 different types of asteroids. And each asteroid can provide 1 or more different types of minerals. And the challenge here is that you need to figure out how much minerals is in each asteroid and how much minerals you can mine out of those asteroids, essentially in order to calculate how much profit you can make off of those minerals. The one key thing I'm going to just address right off the bat here is there is a really important thing that you need to understand if you're attempting to solve levels 4 to 7. And this is highlighted in this kind of point here where it says each asteroid in the field holds X times 1,000 units of ore, where X represents a number in a cell. So for example, in cell C6, it's of the type Veldspar asteroid and it holds 6,000 units of ore. And we can verify that by going to cells in this asteroid field map. You can see all of the asteroids around us. In cell C6, we can see it's a yellow asteroid, which corresponds to Veldspar. So that's correct. and then it has the number 6 in it. So it indicates there's 6,000 units of this Veldspar ore. So I'll go into the mining waste a little bit later when we actually get into the problem. But for now, it's important to note that that 6 or that 1 represents thousands of units of ore. And this is important because when we look at the main asteroid types here, right, we get an overview of these asteroid types, and then we get in 1 unit of ore, that asteroid contains this kind of, we're only focused on the first 4 minerals, which is kind of makes it a little bit easier, but it contains these minerals in 1 unit. Furthermore, it says that for 1 unit of ore, this is the volume that is contained. So for example, in that cell C6 that we looked at the Veldspar, there's 6,000 units of ore. And because 1 unit of ore is only 1.1 meter cubed volume, that means that essentially in 6,000 units of ore, there's 600 metric or cubic meters of volume that is required to mine essentially that asteroid. And that's the kind of relationship that you need to understand well in order to solve these mining problems, because this note is a little bit inaccurate and misleading. Because essentially what this says is, if you're just looking at it, the table above means that essentially 400 units of tritanium contained in Veldspar are contained in 0.1 cubic meter of Veldspar ore. That's correct. That also means that 1 cubic meter of Veldspar ore will contain about 4,000 units of tritanium. That's also correct, because essentially in order to calculate for each 1 cubic meter, you just divide the tritanium by this ore volume in order to figure out. So 4,000 divided by 0.1 is 4,000. 400 divided by 0.1 is 4,000. However, this is a part that is incorrect. This also means that the Veldspar asteroid that is located on cell C6 in the asteroid field map has 6,000 cubic meters of ore and therefore 24 million units of tritanium. We have already seen in the instructions that instead of it containing 6,000 cubic meters of ore, it should be 6,000 units of ore, of asteroid ore. And therefore, in 6,000 units of the asteroid ore, there's actually only 2.4 million minerals of the tritanium and only 600 cubic meters of volume. So essentially, this factor is off by 10. And this is important because this example seems to indicate to the players that the number is actually the volume. So in thousands of volume. So this would be 6,000 cubic meters, but that's not true. It's actually 6,000 units. And so that's the key point to understand when solving the asteroid mining cases, where if you treat it as thousands of volume, you're going to get incorrect answers. It should be thousands of units of ore. So having gotten this out of the way, essentially the layout of the questions are, there's 7 levels. It's levels 1 through 3. Kind of essentially each level builds off of the previous level. The earlier levels are easier. The later levels are more complex. Levels 1 through 3 deal with kind of this ship and cost of building the ship. And then levels 4 to 6 are dealing with mining the asteroids and how much minerals are contained with the asteroids. And then finally, level 7 is the most complex. It kind of brings those two kind of ideas together in order to figure out, based off of the asteroids that you have, how many ships you can build. So what I am going to do, and then there are these bonus questions. So in the competition itself, there's 5 bonus questions. Each of the bonus questions typically relate to a level, and the later the bonus question, the later the level. However, bonus questions are only available to the first certain number of players who answer them correctly. So we can see bonus question 1, only the first 5 players who answer it correctly gets those points. So essentially, bonus questions are kind of a compromise between, do you want to try to solve the main level questions and get a bunch of points, or do we want to try to solve some of these bonus questions earlier so that we don't get locked out by other players who score them? However, for the purposes of our kind of go through, we're actually going to just save the bonus questions for last. And we're going to go through all of the main case level questions. And then finally, we're going to come back to the bonus questions and figure out how we could have answered them correctly. So this how I'm going to go about doing this is I'm going to break this video into 3 parts. This will be part 1, and we're going to be just dealing with levels 1 through 3, using ships and calculating the cost of building these ships. And then in the second video, we're going to go through cases 4 through 6, which is mining the asteroids problem. And then finally, in video 3, we're going to go through the case number 7, the most complex case, as well as all of the bonus questions. So without further ado, let's get right into it. Hopefully we can get through each of these videos relatively quickly, but sometimes going through the explanations can take some time. So bear with us as we kind of look at the questions, look at what this case is asking us to solve, and then using some tips and tricks to essentially solve them. All right, let's get into it. For case number 1, what we're dealing with is it's giving you all of the relevant information we need here, right? We have the price, so it's asking us what's the cost of tritanium that's required to build each of these ships. So it gives you the ship and it gives you the cost in tritanium. So essentially what we don't have is how much tritanium each of these ships require. If we had that, we could just do a multiplication and get the answer in terms of how much money it costs to build. So what I like to do is we're going to have to essentially look up these ships and how much tritanium they require. So, and we have this in this nifty table right here. So for example, a Griffin will require 24,000 tritanium, a Thresher will require 80,000 tritanium, and so forth. So what we're going to do is I like to create just a reference table. We're going to just copy kind of all of the important information of that data. I'm pretty sure we don't need a type of the ship. It's never required. Yeah, it just gives you the name of the ship that you need. So now we have this nice table of Griffin for each of these different minerals that is needed, right? So now we can just do a quick and simple lookup. So what we want to do is we want to say, so amount of tritanium needed for ship. Okay, so tritanium, so we have this ship, so it would just be a simple XLOOKUP. So XLOOKUP is going to be one of those functions that's used all the time. So I won't go into too much detail about how XLOOKUP works, but essentially just pick a value that you need, and then we look it up in any table that we have. So it's in this column of the table. And then what we want to return around it. So we want to return the tritanium value. And then I know there's a lot of shortcuts to kind of referencing cells statically or dynamically and that sort of stuff, but I'm just going to do it a little bit more manual here. So if you put a $ next to a letter, it just makes the column static. If you put a $ next to the number, it makes the row static. So we're just going to make sure that we keep all of these lookup columns static. And so that way we can just essentially pull down of that formula. And now we get the amount of tritanium needed for each of these different ships. And we can easily verify, like for example, the Griffin is 24,000, Griffin 24,000, a Stabber is 540,000, a Stabber is 540,000. So lookup table works well. Now we just need to figure out the cost, right? So cost or price of the ship. So in tritanium, because that's the only mineral that we care about for now, in this case study. So this would just be equal to the amount of tritanium needed times the cost of the tritanium. And we got essentially our answer. The one last thing that the question asks us to do is report it in thousands of ISK. So final answer would just be equal to round, because it does ask us to round this to the nearest thousand. So this divide by 1000, and then round it to the nearest integer. And we can see this answer corresponds to this example answer, which is correct. So that is very promising. So we're just going to drag this down, and we are going to copy our values here and hopefully get all of them correct. Cool. So now we have 100 points on the board and we are on to level 2. So what's the total market value of each of the ships below at the mineral prices provided? So now essentially we just add another layer of complexity. We have the ship, except now we need all 7 minerals rather than 1 mineral. This is still fairly easy to do because essentially we just use that same lookup table, and we just need to grab the amount of minerals for a ship needed for each of these minerals, right? So we already know how to do a VLOOKUP for the tritanium, which is exactly what we did here. We just do something very similar where we do our XLOOKUP of the ship, and then we find the ship in this table, find the tritanium in this table. The only difference is we want to keep this column dynamic, because as we drag across, we want to figure out for Griffin how much tritanium and then pyrite and then mexilon and all these other minerals that's needed. We still keep the ship lookup static because it's only in column A. And we want to keep this, the specific value of the ship lookup, this one column, because it's also static, because it's also only in column G. However, as we drag across rows, we want to make sure that the rows change. So by doing this XLOOKUP, I'm pretty sure, yeah. So for Magathron, this is the amount of minerals required to build it. So 8,000 down to, or 8 million down to 3,000. That's exactly what we get here. So now we drag this formula all the way down. And voila, we got all of the minerals required for building all of these ships here. Now, the second part is we just need to calculate the price. And we have the price for each of the minerals. And essentially, what we want is an Excel formula that can do the cost of the tritanium multiplied by the tritanium price, the amount of tritanium, and plus the amount of pyrite times the pyrite price, plus the amount of mexilon times the mexilon price. And so you can see we do some sort of multiplication and then sum up across the rows. And there is a very nice nifty formula in Excel that helps us do this. So total price, and essentially the formula is just a sum product. So equals sum product. And so it just takes in 2 arrays. So we're going to grab this array and we're going to grab this array. And essentially what it does is it multiplies the first item in the first array with the first item in the second array, and then add the second item in the first array times the second item in the second array, and continue to add and so forth. And so this should give us the total price of the ship in terms of the mineral cost. Once we get that, notice how this, even if we converted this to 1,000, it's about 330,000, which is still a little bit wrong. And that's because in the directions, it adds another kind of twist to it. It says producers add a 10% markup to the raw material costs. So essentially, all that is we just need to, for the final answer, we just need to take this value and multiply it by a 10% markup, 1.1. And then we also want to report it in thousands of ISKs rounded. So round this times 1.1 divided by 1,000 and round it to the nearest integer. So now we have 363,721, exactly what we get for the answer for the example. And so now we just drag this down, and we can copy these answers into this column. And that should be correct. Yes, we are at 240 points. And for our final kind of level 3 related to the ships, this is a little bit complicated now. Now we still build off of kind of what we've done in the past, but we have multiple ships. Right now, for example, in this case, we also don't know the price of the materials, but we do have a date. So remember this adding output where we can find the price of the minerals. So with the date, we can use that in order to look up the prices for each of the 7 different minerals. However, the tricky part immediately that we see here is that now we don't have a nice way of pulling the type of ships, right? So we have a background color. And so essentially what this information is telling us is that for this fleet composition of 5 groups, it has 10 of these hand color ships. And if we look it up, those are drakes. And then we have 11 of these red color ships. And if we look at it's the stabbers. So if we kind of combine them together, we know that there's a total of 32 drakes and 22 stabbers. But that's really difficult to like just know because for example, we'll need to figure out like kind of the composition of the fleet for all of these 20 cases. So right off the bat, the first thing that comes to mind is, well, we need some way to identify, okay, based off of these colors, these are the ships. So if it's a gray color, it's going to be a griffin. If it's a purple color, it's going to be a thrasher. Now, I'm sure there might be some clever way for filtering based off of background color, but like I said, I'm not the most familiar with Excel. So so I wouldn't know how to like kind of really quickly do that, identify the number of ships. So instead, I'm going to rely on a little bit of coding and a little bit of kind of tricks in order to figure this out. So what I'm going to do is I'm going to pull a background color for kind of these ships. And how I'm going to do that is I'm going to go to developer. We're going to go to Visual Basic. We're going to open up a case and create a subroutine. So we're going to do so essentially subroutines are just kind of code macros that you can run on a spreadsheet. So we're going to say ship color and I don't think I need the quote marks. Okay. So ship color and sub to end the subroutine. And we're going to save this because right now this is just a macro-free workbook and we want to save it as a macro-enabled workbook. So we choose no. Let's just save this as a Eve case study. I don't know. I'm horrible with names. Fresh. One with macro. And should be. Oh. No, we want this to be a macro-enabled workbook. Save. Okay. Cool. So now we can start writing some code for it and see kind of how we can go about doing that. So the first thing off the bat that I know is we want to go through these rows. So row 32 through 36. So we need a way to identify rows. So we're going to dim a row variable. So row as integer, and then we don't necessarily need a column for now, so we're gonna say, and we're gonna loop through the rows. So for row equals 22 to 25, I think. Next row. Okay. I don't think I remember the row correctly. 32 to 36. Okay, 32 to 36. Whoa. 32 to 36. Okay, what do we want to do for each of these rows now? What we want to do is we want to pull the background color for kind of the cell in row 32, column O, and that is column 15. So essentially what we get is cells, row 32, column 16, dot interior, dot color. And I think that pulls us the background color of that cell. And so the important thing to note here is, and we'll just assign that as background color. And the important thing to note here is initially I tried using interior.color index because a lot of times you work with color indexes. It's a nicer integer to help you differentiate the main colors in Excel. But the one wrench in that plan is here, if you pull the color index of the Griffin, it's the same as the Drake. And that's because how color indexes work is there aren't enough integers to distinguish just stored in kind of the color index reference to distinguish between all of the different colors or shadings. And so you run the risk when you use color index of two colors are either similar or just doesn't have a well-established color index to return the same values. And so essentially when I use color index, it just gave me that the background color of the Drakes has the same color index as the background color of the Griffins. So that's not going to help us. So that's why here I'm actually just directly pulling in the interior color. So it gives us a really messy string that relates to the background color, some sort of hexadecimal to decimal kind of conversion there. And the important thing to note is this value is going to be unique for all background colors. And then finally, we want to like essentially write down this color so into the cell right next to it. So what we're going to say is cells I17 dot value equals the background color. And that's all there is to it. This little bit of code ideally should put the background color of all of these backgrounds right next to a cell. And let's try running it and see what we get. Uh-oh. We don't have a range. Oh. So I use I. I'm just so used to using I. That should be row, and that should be row. Here we go. And then we'll run this. Just ran in the background. And is this row 15? Yes, not 16. So I was off by one row. So this should be 15. Sorry, one column. And this should be 16. Okay, so let's just remove these values and then rerun this macro. And then we should get, nice, see? We get some different background color values, and they're not all the same. Like, yeah, they were the same for white because it was trying to find the background color for these. Here we can see, okay, we got this background color for each of the 5 different ships. We have a reference table here. So we're just going to put this in and we'll just do background color. And that should help us answer case number 3 or level number 3. So now all we need to do is because this is very difficult to read based off of color, let's just go fleece composition by ship rather than by color. So now we can just do a, let's see, what, so we need to go fleet composition by background color. Okay, so we need to pull the background colors for each of these ships. So our end result is we want this to return like Stabber or Thrasher or whatever, Drake. So we want to essentially have this return like Drake and then Stabber, Drake, Stabber, Drake. In order to do that, we need the background colors for all of these different cells. So remember our original VBA code here for ship color? Well, why don't we just modify this in order to pull the background colors to kind of these cells that we need. So what we want to do here is we identify, so starting on row 141 to row 162, we need to loop through those rows. So 141 to 162. 141 to 162. And then we also need a column, because we have 5 columns, right, of ships that we need to loop through. So we have the alpha, beta, gamma, delta, epsilon columns. So for column equals 1 to 5. Next column. Cool. Now we just need to figure out how to pull the background color. So right now we're pulling the background colors of row 141, but what column do we need for row 141, right? And so what essentially we want is this column, because then when we increment the column, we can just add one, add one, add one, add one, and then we go to the next row and then increment through the columns here. So this column I, is the ninth column. So essentially, if we define column from 1 to 5, what we want is 9 is equal to 8 plus the column variable or integer. And so that way, when the column increments, it goes from 9 to 10 all the way to column 13. And then what we want is we want to split out the background color into this column. So this column O is the 15th column. So once again, it would be 14 plus column. Right? And I think that is all of the coding that we need to do. And we will give this a run. And then hopefully, yep, we get to pull all of the background colors of these cells. Pretty nifty, huh? And pretty quick to do. So now that we got all of these background colors, what we can do is we can do the fleet composition and get at essentially what we wanted to get at initially, which is we want the ship itself. And this, once again, will just be a lookup table. So equals X lookup. We have this background color. We have the background color, and we need to pull the ship. And so essentially this will be static. The background colors don't change because there's only one row for the background color. There's only one row for the ship, but this will be dynamic because we need to identify all of essentially these background colors and how they relate to ships. So now we have Drake, Stabber, Drake, Stabber, Drake. Perfect, exactly what we need. And we can drag this down and we get all of these kind of different ships. And if there's no color associated, it's going to return not available. And we don't really need to worry about the not available responses. We just care about the ships that actually exist. Cool. So now what we want to do is transform this data by total fleet composition by ship. Because once again, we have 5 different types of ships, right? We have Griffin, Thrasher, Stabber, Drakes, and Megathrons. So we want the total number of ships that's available here. And so what we can see is for Griffins, we just essentially want to identify any of these that are Griffins and then count up how many are in the corresponding cells. Same thing with Thrashers, Drakes, Stabbers, and Megathrons. So this would just be a simple sum if formula. And so for the sum if, what the criteria range is we're going to take a look at this range. And if any of those values equals that criteria that it's a Griffin, we want to sum up these values. And then I'm just going to do a little bit of manipulation for making it easy to drag the formula across. So we keep that static. We keep the row static for here, and we keep, once again, the column static. So now, if we drag this across, we can see that there's 22 stabbers and 32 drakes, which is exactly what we want. And if we drag it down, we just have a nice total composition of ships. Like here we have 1 griffin, and there we have 6 griffins and 3 thrashers and so forth. So now that we have the total composition by ship, we can go ahead and solve for the value of the ships, right? So what we need now is the total mineral to build these ships. And so we need to pull across all of our minerals. So let's see, where are our minerals information? We have ship info. Here's the mineral information. Here we go. And so we have all of these minerals, and we just essentially need to figure out, okay, for this composition of ships, how much titanium, how much pyrite, how much all of these things that is needed, right? And so the easiest way to do it is by trying to figure out how to do a product. We want, essentially what we want is some product of this composition, and then we want, for example, for the stabbers, so for the griffins, I see. So we want to essentially multiply the titanium cost of the griffins with the number of griffins, the number of thrashers with the titanium cost of the thrashers. So essentially it's this column that we want to pull. However, this one, so this is a row and this is a column, so we do need to transpose this. I think that ends up getting us the amount of titanium that is needed for this fleet composition. We want to keep this static, and we want to keep the rows static. And if we draw it across, I think this will give us the amount of minerals required for this fleet composition. So if we drag it down, this should give us the price for kind of all of these ships. So for example, it's really easy to check. For 1 griffin, it should require 24,000 titanium, 4,500 pyrite, and so forth. 4,500 pyrite. So it seems like this table has been verified and correct, that this will be the total amount of minerals to build the ships. So now the second to last part is figuring out the mineral prices on the given dates, right? So a couple of things to note here. These dates are a little bit awkward. For example, I'm not too certain if you could just do a VLOOKUP based off the format of the date we have here. So what we're going to do is we're just going to convert these dates into an easier format I know that works. So essentially it just equals to date, and we're just going to pull the year of this date, the month of this date, and then the day of this date. And so now, instead of doing this whatever wonky format, we have a nice kind of date format to work with. This is going to be a non-existent date because we don't have any information. There's a gap between the example and the actual cases, but these are the dates for the actual cases. Now we need the prices for these materials. And so the easiest way to do this is in our adding output, we can kind of take a look. We need to identify kind of the dates, so we can do a lookup and then the prices for each of these materials. So one other thing that you can kind of check is these are cards and they're not actually good dates. So what I mean by here is, for example, here, let's try to see if this date is equal to, if this date is equal to this date. It seems like, or sorry, here, let me do it a different way. Let's say we have a date that's like 11/27. So this is a date, right? So if we wanted to check if this date, 11/27/2023, is equal to this date, 11/27/2023, if it is equal, then we'll return yes. If it's not, we'll return no. Notice it returns no. This seems to indicate that if you just did a lookup on this value with this kind of column, it's not going to match. It's not going to it doesn't think that this is equal to this date. And the reason behind it is because there's a lot of information here. While it displays a date, if you open up the card, you have like the average date, highest, lowest, and all of this extraneous information. So what we need to do is extract the actual date from here so that we can do a lookup. And the easiest way to do that is just to pull out the date from this card. Let's see if we can pull out the date. And we're just going to populate the date for all of this stuff, right? And then what we're going to do is we're going to create a column that's just date. And we'll use the same trick that we did last time. So equals date, year of here, month of here, day of here. And now we have a date that hopefully we can work with, right? So now let's double check. So let's try to see if this date 11/27 is equal to the A4 date. And it is. So A4 would be this date. So now, because it is, we can work with that A column in order to pull the prices of these minerals. So once again, this will just be a simple X lookup where we look up the date, and then we look up this array, and then we output the price of the titanium. So it's actually C. And if it's not found, we'll just return 0 or something like that. Or we'll just return NA. So that way we can spot if there's any issues with our code. So we'll kind of make that static. We'll make A4 we will make that. So essentially what we need to do is copy this formula across and update each of the columns for the relevant columns here. So for example, we have F, GHI, JKL. So it seems like every 3 letters. So we'll start with F. And then GHI, JKL, MNO, PQR, STU. And the reason I'm doing this way is so in the future, we're going to be reusing this formula in order to grab the prices on any given date quite a bit. And so this formula just makes it easy so that we can just copy this and paste it elsewhere in order to grab the prices for a certain date. So now that we have the prices for a given date, and then the total minerals to build the ship, it should be just a simple of total price of ship. And once again, do we need that 10%? I think we do need a 10% markup, right? So we're gonna do, this is just a sum product of the prices of the minerals times the amount of minerals in the ship multiplied by 1.1, 23056. So about 2,306. Yep. Millions, because specifically it wants you to report your answer in millions. So if we drag this down, this will be the raw total price, and we're going to report in millions. So answer equals round this divided by 1,000,000 and then 0. So 2,306, and that's exactly what we want matched up with our example one. So now we just paste, and voila, we have finished level number 3, and a total of 420 points. Tune in next time as I kind of tackle the asteroid set of problems and see how we'll go about approaching that. Take care and catch you guys around. Hope this has been useful.